data analytics very successfully, which we like. And then we see companies that are not so successful. And what I try in my talk today is to deconstruct those companies and individuals that do data analytics very successfully, so that make millions of data science. What do you think, what is the #1 challenge of companies doing data analytics nowadays? Oftentimes we hear data is a problem. I actually think of what I see in industry, data isn't really the problem, right? There's a lot of companies that have figured it out how to provide data to an algorithm, to feed data through various systems to a platform. There are solutions out there. We at SAS also offer a solution. So if you want, you can do it, right? And companies generate petabytes of data. We know that. Second thing, algorithms. Everybody has algorithms. There's small differences there between, do I use a tree learner, do I use a neural network, what kinds of analytics tasks do I have? Algorithms are out there, right? It's available. What's also out there is use cases. So whenever we talk to clients, they have hundreds of ideas of use cases they want to do. So the mission, the vision in most companies is there. They want to do data science, right? I've hardly met a company that doesn't want to digitalize their business. The real problem that we see, and this ties to the use cases, is that some companies have the death by POC. So they do a lot of POCs, but then nobody deploys the solutions. And this is really what hurts me. And as a data scientist, I asked myself, why do we not deploy? Because it's really everybody's job, right, to deploy an algorithm. And I think part of it is because we built this little baby, this algorithm, and we don't want to throw it out in the wild, right, where the lions can catch it and tear it up, so to speak. So we don't want to have our cool little program that we developed, give it to hypercritical engineers who will rip it apart and tell us about all the things that don't work. So if it works to 99%, you won't hear the 99% that work, but you will hear the 1% that doesn't work. But that's the very important step to do. I think this is where we really have to push ourselves. Yeah. And another reason is doing proof of concepts is fun. Yeah. So the data scientists among you, who of you like to do a POC? Play with data, deploy algorithms. A few of you, yeah. It's fun. It's fun to do POCs. It's nice to read image data, read text data, deploy your algorithms, play with it. Yeah. But then, usually, what we do a lot of POCs, but only a few of the solutions we build really make it into deployable algorithms, because deployment means hard work. So doing proofs of concept is fun. Yeah. This is the playful part of data science. And oftentimes when we deploy something, it becomes a software engineering project. So it takes months to deploy an algorithm until it's really done and can be used by everybody. But unfortunately, those deployed solutions are also the solutions that generate money. So those are the little robots that crank away all the time while you sleep and do the job for you. So this is actually where the money is made. So the question is now, how do you come from a lot of POCs that are actually fun to do, but they don't lead anywhere, to the one solution that actually generates money? And this is, you have to deploy fast. Yeah? I think data science is not a technology-driven field. It's a field that is driven by the use case. So sometimes a good use case with simple technology, with very simple algorithms, that is deployed, generates much more money than an algorithm that never gets deployed but has the most fancy technology. So rule number 1, deploy fast. I'm sure many of you have seen this life cycle, right? Some people call it the crisp DM. the cross-industry standard for data mining. We at SAS, we have the model lifecycle. And when we talk about deployment, I talk about the stage in the middle, right? So I talk about, let's do the data prep quickly. Let's eat our vegetables, as I call it, yeah. Make sure that your data is okay, explore, model, and then go to a first prototype very quickly. This is very hard, because if you do this, you can fail, yeah. And that's why I want to demonstrate to you live today what this means if you have an algorithm that is not really finished, yeah. We've prepared something nice that I called the non-drone demo, because the Hofburg venue actually doesn't allow drone flights. So please give a round of applause to Gerhard. He's one of our most senior data scientists. And he will demonstrate the drone flight today, because I'm not allowed to let the drone fly in here. Okay. So, as I said, this prototype is half finished. So a client approached us and asked us if we can do something with drones. We said yes. And we basically built and deployed the model in a few hours. So we didn't spend more than 4 hours on this prototype. So if it fails, please have mercy on me. And I will explain how we did it in the next slides. So what I have to do now is I have to start up a little real-time streaming server, as we call it, streaming engine. So for this, I have to start a Docker container. Let's hope that it runs. Yes. So, and then I open a Jupyter notebook. Are you excited? I am. Okay. I literally lost sleep over this. So start this Jupyter notebook. So then we switch on the drone. Okay. Is it blinking? Yeah. Okay. And then let's pray to the data gods that this works. Here we are. So what this actually does is we put a tiny YOLO model on this drone. So tiny YOLO detects about 300, maybe turn it my way, because otherwise we crash the computer. It detects 300 objects. And the idea was to switch it down to detect human faces and human bodies. So this is what I switched on now, so it detects my face and my body. And that you see that it's not only working for me, it also works for Gerhard, right? Now it crashes, and it also works for everybody else, yeah. So this is something, so thanks data gods that this worked. We can switch back to the presentation, by the way. And thanks Gerhard. Yeah, give it up for him. So, I mean, everybody can deploy a YOLO model, right? Or run a YOLO model of your camera on your computer. But the cool thing is that we were able to do this within a few hours, right? And it doesn't work perfectly, so there was a 50% chance that this wouldn't have been working today. But it's enough to take it to the client and show to the client what a drone use case looks like before you have even had a first meeting. And I think this is quite impressive, yeah. And to show you the actual idea of the demo, when the drone flies, yeah, it would have looked like this. What we programmed in here is that it recognizes the face and then moves toward the face. Yeah. This is a very high professional video that I recorded yesterday. I always get a little bit scared when it comes close, but it does the job. Yeah. When you move back, it moves back. And then when you can trace objects and save the geographics data, GPS data, you can do a lot of interesting stuff. Yeah. Unfortunately, I can't go anymore. Yeah, now it crashes. Let's move further. And so how we built this is a few technical details. So we have something called an ESP, so event stream processing. This is a SaaS product where I can stream real-time data. You don't have to save the data. You can analyze it real time and only save the results, right? So this helps you. It's faster, and it also saves a lot of data transferring. So especially if you work with images, this helps a lot. Yeah. And we deploy the tiny YOLO model in it, and then we make the images smaller so then YOLO can read it and export the results. Yeah. And we do this with a Jupyter notebook, as you have seen. For the geeks among you, I have also some further reading. I won't take you on the GitHub pages now, but there's some description how to use YOLO and our deep learning library with SAS. Yeah. So this was point number one. This was successful. Yeah, how to deploy fast. The second thing that I see is kind of paradox, and I'm also part guilty about it, because we as data scientists, we are very proud of our work, right? We are very proud that what we do is magic and nobody else can do what we do. It's partly true, yeah. But on the other hand, especially in industry, we work with physical processes. And most of the times, data scientists don't really understand the physical processes. And I also have a little demonstration for this, without a drone this time. A little riddle, yeah. So what is this? Scream it out. A cat, yeah, very good. This is Katzi, yeah, this is my cat. She's from Texas, she's at home at the moment. And then I have a second question, what is this? Heat transfer, very good. I was afraid that somebody would know this. So I have another one. What is this? Okay, now I don't have any other ones. But at least there was only one person who knew it. It's the Navier-Stokes equation. It was once called the most ugly differential equation in physics, or in engineering anyway. I'm an engineer. But how does this make you feel when you see this stuff? Yeah, I mean, I always get this strange gut feel, right? Right? I failed in fluid mechanics once, so the Navier-Stokes equation is deeply ingrained in my memory. But these people, this is domain know-how. So this is what people always call, you have to integrate this in your models. Domain know-how is very important. Yeah? When you show this to a guy who has studied statistics, he asks you if you're crazy. Yeah? And if you compare it to the other one, yeah, that pretty much everybody knows, you see one of the main challenges of doing analytics in industry. Because Facebook and Google have an advantage, right? Because they work with know-how that is very easy to grasp. Yeah? You can send photos like this to a low-income country and have them tag the photos and say, this is a cat, this is a dog, this is a squirrel. Yeah? If you send them the Navier-Stokes equation, I'm not sure if you will get good results. Yeah? So how can you overcome this problem, right? One option is that we teach every data scientist what a Navier-Stokes equation is. Maybe it's not going to work. The other option is that we give data science tools to non-data scientists. And this is something I really believe in. And I see that some of the especially in the corporate world, data science departments, they're sometimes hesitating to do this because they want to keep a part of their magic. But I think the pie gets bigger for everybody, because if you have a Navier-Stokes equation for some fluid mechanics or problem that you're trying to solve, yeah? And if you go from there, you need to invest much less time in model training. So in training time and in time in preparing the data, you can just run the physical model and then build a data model on top of it. And this is, I think, this is where data analytics becomes very powerful. Yeah? in industrial applications. So this is summarized in this slide, that there's always a field of tension between data science and engineering know-how. And this needs to shift. Yeah, so it's not every problem in industry is automatically a physical problem, but mostly you're somewhere on this spectrum, right? So either you're going more towards machine learning models, so where you don't need a lot of domain know-how, just a little bit. There's usually always a little bit of domain know-how involved. And then there's tasks where the actual difficulty is to build the physical model. And to understand the physics behind the problem, and the data model is just a linear regression. Yeah, this also happens. This collaboration can have different forms. Yeah. So for example, giving the tools to the non-data scientists can mean just give them options to visualize the data, pull it together, run some charts. Yeah, this is what you see on the on this side here. Once the model complexity increases, but you maybe only have one application for it, then it's maybe still the option that you write down formulas together with the engineer. Yeah, then you involve the formula, you engineer new features, yeah, and then you build a data science model on those features, and then you try to tune it, maybe build new features. When you try to scale this, you need to work with templates. Yeah, you need to have pre-prepared templates of code with pre-prepared features, and then you can just run the whole thing and apply it to, let's say, 1,000 or 100 applications and see where it works and where it doesn't, and then you tune the applications where it doesn't perform. So this is a very important aspect, I think, of doing data analytics in industry. So once you have accomplished this, yeah, once you have 100% buy-in of all your domain experts, yeah, and you're really good at deploying fast, and you have a lot of models, what happens next? You have a model zoo, yeah? So you have a whole bunch of different models that are cranking away, work at night, generate a lot of cash for your company. And then what happens, usually this is a little bit of a paradigm shift. Then it becomes from pet projects, it becomes to money making, gets to money making, right? And this is the step where data scientists learn that when their model isn't working at midnight or at 3 a.m. in the morning, that they have a problem, right? That they get calls on their phone. And this is also where you need to professionalize the way how you maintain models. Yeah? And think about how your company would look like when you have in future maybe thousands of models. Yeah? And I like to compare this to the human workforce. Because nowadays companies have thousands of employees. And what do you have in place to make sure that all those employees do actually something that is productive and that makes money for you, right? You have to manage them. You have to make sure they're well trained. There need to be clear decision processes. It's like every company works like that, right? Everything's perfect. And you need performance control, right? We need the same thing for models. So when you think what your company will look like 3-5 years from now, you will need something like an HR for your data science models. So maybe then you have still 1,000 employees, but on top of that, you have 1,000 models that you need to control. Yeah. This is what we call the model manager. So we have some piece of software that controls your models, that retrains them if they're not good anymore. If retraining doesn't help, they get fired, yeah, or retired, as we call it, because it's less provocative, I guess. And we see this as a highway. Because the reason why this is a highway is because you have to do this fast, right? So when you find out a model isn't working anymore, and maybe this model is critical for your production or for the way how you make decisions in your company, then whatever you do with this model, you need to do it fast, yeah? Otherwise you have a problem. And then you have the option either re-diagnose or redevelop. If it's working well, you just keep going on the highway, you go straight, right? Or if nothing else helps, you retire it, you fire it, yeah? This is why I compared with HR. And these are a few screenshots how this looks like in our platform. So we can monitor here 4 different models, yeah, for different kinds of indexes. And the neat thing is, you don't need to do this manually. You can set up a decision process, right? So when you find out you have a model that always screws up after a few weeks because the training data changes so much that you can't cover it with one model. It just doesn't generalize. Then you need to set up an automatic process that takes this model and retrains it on new data. Yeah. Or you need to have a bunch of competitors, challengers. Yeah. And if another model works better, the old model just gets replaced with a new model. Yeah. And you can also decide if you want a human in place, or if you want to have this automation tool make all decisions for you. Yeah. So and once you have all of this working, then you can really do analytics on an enterprise level. So then you can run algorithms for really thousands of applications at the same time, keep them in control, yeah, and you can put it all together. And I've prepared one little video how SaaS did this at Volvo Trucks. So let's hope this works. Yeah.
Analytics is more than just a buzzword at Volvo Trucks. We're using it to rethink a lot of the ways that we've done business in the past. In 2012, Volvo Trucks launched remote diagnostics. It was really a game changer in the industry. Remote diagnostics was taking the fault information in real time coming from a truck, diagnosing it, and giving information to the customer.
We're capturing a lot of data. The information over the variety of engine emissions has made that data more complicated and complex.
So we needed a platform that really could not only meet the needs what we have today, but that we can scale to the future.
Having an analytics tool like we have with SaaS has helped us to become more informed and see trends that we would not have seen before.
So some of the issues we're seeing in the field are software related. So we're able to update the truck over the air without disturbing its operations.
It's about peace of mind and helping them understand if the code they see warrants immediate action, and if it does, we contact our dealers. We have the service event repair planned and all the parts needed available when the vehicle gets there. So when the vehicle enters, we're able to watch, monitor, and track through the repair cycle, make sure the repair stays on schedule as planned and gets back in service at the committed time.
We're able to see that much quicker now with this real-time streaming data. And so that helps us communicate back into our engineering group that we're seeing an issue out there, maybe even before it's really impacting our customers' operations. So with remote diagnostics, we're already seeing that we're saving a 70% reduction in diagnostic time and a 25% reduction in repair time. That's huge savings for our customers and making sure that when they have a truck that has to come in for service, it's done quickly and accurately. Our partnership with SaaS has been very fruitful. In many ways, we're on the cutting edge of technology when it comes to analytics and uptime services, and it's a pretty exciting place to be.
Good, that was my talk. If you have questions, please ask. I'm happy to answer them all. Thank you.
We do, in fact, have a couple of questions in Slido, so we can go through them. If you have any more, feel free to post them, or I'm sure that you'll be happy to answer them in person after the talk. So
Sure.
let's move on to the first question, which is more practical. What's the model you used for the demo?
It's a Tello. It's a DJI Tello Toytron, and it comes with a software development kit, so you can talk to the drone with Python.
It's a really cool one, really cool use case. So
yeah, it's a pity that I couldn't fly it. So if there's anybody here from the Hofburg, maybe next year we can fly around with it.
Yeah, we'll program something together. There are probably a lot of keen developers to try this.
Yeah, yeah.
All right. So our next question and last at the moment is: can you name some specific best practices for using domain knowledge in data science projects?
Yeah, that's a good question, because one of the main problems is, I mean, the normal approach is you do workshops, right? So you put the data scientists together with the domain experts, let them talk to each other. One of the main problems that I see is that both groups of people are kind of introvert. So I don't want to hurt anybody's feelings, but normally both domain experts and data scientists are not the most outgoing people. So I'm not sure if it really works so well. That's why I said give the tools to the guys who have the experience and who have the know-how. So this is really the best way to do it, to democratize data analytics and let them play with the data themselves.
Mm-hmm. Thank you. We have a question about the Volvo example. Who orders, buys, pays the service? Can you elaborate on that?
Yeah, so there's a cooperation that we have with Volvo Trucks. I think the way it honestly, I'm not sure what the business model behind it is. I know that it involves streaming data and that we stream the data directly from the trucks. But I think it's a typical dealer vehicle situation. Yeah, we have car dealers who do the service or truck dealers who do the service, and those are Volvo dealers. So we cooperate only with Volvo in this case, not with single repair shops, if this is the question. Yeah.
Right. So the next question is also considered the example at the end. So can this track model be implemented for on used tracks 15 years old, for
if
example?
it's connected, yeah, and if it has the data, yeah.
Also, can you explain an example for a tool to let citizens data scientists work?
SAS, of course. No, we have. So what we have is, it's called visual analytics. So we work out of one platform, and that's actually the idea of SAS Via, that data scientists and citizen data scientists work off one platform. So you load in the data once, then you generate reports in visual analytics, and you can create out of those visual analytics reports, you can actually create already models, and then the data scientists can take these models and put them in production, tune them, put them in production.
All right, so we have a last question here. Which models you used for the remote vehicle maintenance use case?
So this uses all bunch of use cases, all bunch of models. Yeah. So usually, so I can't really tell you what particular models we used in this case, but typically we would use anomaly detection models. So everything that goes in anomaly detection is, so you can use clustering, you can use robust PCA, you can use something called support vector data description, you can even use control charts, or use the anomaly detection model as the basis and build a control chart on top of it. So whatever is robust, yeah, for this use case. But normally you're looking for something, for defect that you don't even know beforehand. So you need to model something that you don't know. This is difficult. That's why we typically use unsupervised learning for this. Unless you have a machine that breaks a lot, yeah, but then maybe data science is not your main problem.
All right, we still have time for the last question that came in. So have you any other projects in automotive sector?
That's a good question. American Honda, yeah, and I think also Toyota. But American Honda uses text analytics to analyze repair. We also work with agricultural companies. So whoever asked the question, you can send me an email and get back to you with all the details.
All right, Manfred, thank you so much for sharing the talk, and thank you for answering the question. Manfred Kügel, everybody.
Thanks for the nice intro.